Previous class, we already discussed example 8. Again, now we are at chapter 6, where we deal with rigid body. So you're given, for example, a body like this. So you see this one is a rod. So you know that when you deal with rod, you have a reference point O, and then you are given the moment here. It's a moment, 60 Newton meter on the rod, and there is an angular velocity of 5 radian per second. Okay. Now, before you do anything, you know that this is rigid body. So the first point is to identify where is the center of mass. Even though in the picture there is no center of mass. All right. So instinctively or naturally, you should quickly go and mark the center of mass at the center of the rod or center of the object. Right. So that is just a steps for you to solve when it comes to rigid body. So you're given a mass, you're given the angular velocity. You need to determine the angular acceleration. You need to determine the alpha. So alpha, and then horizontal, vertical component of reaction of the pin on the rod at this instant. So there's a pin here. So pin, you always have the y and x forces, right? So yeah, so if you really don't know how to analyze the whether go up or go down, you just imagine you are the pin. Then you reverse the direction for the other body. Understand? Yeah. Okay, so for example, this case at point O, you are holding the rod. You're holding the rod. So the rod actually have mass to pull you down. So actually the force is go down, and then it rotate. It rotates, so you are tends to like shift to your right lah. It shift to here. Right? So you reverse it for this one. But anyway, if you really don't know, then you just put positive y, positive x to the point O. And then when you calculate, you get negative or positive. Then you flip the direction. Okay. Okay, free body diagram. We are focusing on this rod. So we have pin. So you just put in the center of mass. Center of mass at center. So you're given the weight, the mass. So turn this one to weight mg. Okay. All right. Then next one. Once you have put in all the force already, then you identify what kind of motion you have. Is it linear motion or is it collinear motion? Now you focus on the center of mass. Focus center of mass. So in this object, what kind of motion will center of mass moving? Is it move in a straight line or it move in the collinear motion? Collinear motion. So when you move in collinear motion, you know that you have normal and tangent already. So once you have collinear motion, you know where is your velocity, where is the acceleration direction. Then rigid body, you have and this one was rotate with the angular motion. So angular motion you link, especially it tell you that this is angular acceleration you need to find, alpha. So alpha, you try to think, V equal to omega R. Means you link with the angular parameter, V equal to omega R. Then what about acceleration? Acceleration you have two, AN and AT. AN is no, link with omega. I will link with angular parameter now. AN is the normal, they call normal in the like normal acceleration but you have to link with angular parameter. So AN is what? No, alpha is omega square R. Okay, tangent is alpha R. Okay, so this one you have to like know already, like G equal to 9.81, like it's very common, very natural already. So all these things you have to look at the question, you look at, okay, angular acceleration. I have a moving object. So how do I link with the information I have? So this is the angular velocity and so on. So back to free body diagram. You put in the forces, right? So nothing complex here. right? So O, you have tangent, normal, or X and Y. But in this case, because it's moving in the circular motion, so you put normal and tangent. You put X and Y also, I'll give you correct. Yeah. So you have a moment, you have okay. So free body diagram, you deal with a moment, you deal with force. Then kinetic diagram is only deal with acceleration, right? Acceleration of velocity lah. So in this case, so you link with MA. Again, rigid body, you no longer see acceleration as standalone parameter for kinetic diagram. Okay, rigid body, you need to change your acceleration multiplied by the mass, you get forces. MA in the kinetic diagram. So MA at where? MA, when you use mass in rigid body, it always go through central of mass. Remember that, huh? Okay. So MA, your A is, in this one is tangent direction. Okay, tangent, sorry, just now I say tangent is, tangent correct, huh? Tangent is alpha R. Okay, tangent is alpha R. Then this one, normal is omega squared R. Okay, so remember this one, so tangent is alpha R, normal is omega squared R. Okay, what else? Yeah, then you have one more, which is Ig alpha. Rigid body, kinetic diagram, you have Ig alpha. Okay. So once you know to build your free body diagram, you know how to build your kinetic diagram. The next step is you use F equal to ma and then sum out all the moment. This one. Then the rest is just mathematics and try to find the missing parameter. Okay. So equation of motion, you have these three. So mg, moment at G, you have two sides. One is free body diagram, one is kinetic diagram. So mg equal to Ig alpha. So you just put in what you see here. So at the G point, don't put at O. If you do O, this one become IO. IO equal to Ig plus MD square. Okay. So there are two ways of doing it. Either you're focusing on central of mass or you focus on the reference point. There are two ways of doing it, right? More direct one, you just focus on the central of mass. Okay. So the rest you just fill in and then you solve for the missing parameter. Okay. Where to find Ig? From the table. Okay, from the table. This is a rod shape. Okay. So this is a rod shape. So here. Okay. Here. How you know which one? Your G is at where? Center, right? So refer to this one. There's a G point here. Okay. Center of mass. G point. So G point is at where? X and Y. So it's IXX, IYY. So it's 12 ml square. What is L? Length. Okay, you copy this one and then you put into IG. Yeah, nothing complex here. So the rest you just do as normal. Then you solve and you get the alpha and the forces at O. Okay, try to identify the steps and the procedure rather than go and memorize or chase after the numbers. Try to understand why we do this or what are the SOP. First step, what I do. Second step, what I do. Right? And you observe all the example. Actually, there's a certain sequence of doing things. So there's a certain steps fixed already, right? You just follow, right? Then you're able to find the answer. Okay, then once you find, this is a second method lah. Second method just for your info. So second method is that again, this is using O point. The previous one we have focused on G point. Now second method you focus on O point. Again, IO equal to IG plus MD square. So you see the equation. there's a change of equation over here. So this is moment. Moment at O, you close here. So no force here already. So you only have one weight here. So free body diagram, you have weight, and then what? And then there's an additional moment given by the question. So 60 given by the question. So then the kinetic one, you close O, you see this one and this one. Right? This one will create moment because MA is a force. Force multiplied by the D, you get moment. Right? And then this one, okay. Right. There's something missing in my equation here. Do you see something missing? Do you see something missing in my calculation? What is missing? Huh? No, no, here, moment. We deal with moment. This moment. This one, you already find W and moment. This one, kinetic diagram. You close at O. What do you see? This component don't have moment. This one. Then what about this one? What is missing? G. Then what is missing? This purple color is moment. In my calculation, I missed something. What is this? Half, 1/12 ml is what? This one. Then what is missing? Huh? Huh? Acceleration is A. Is there any A here? What is missing? What is missing? Very direct. What's missing? Yes, focus on G point, but this is focus on moment. No issue on the free body diagram here, but there's something wrong with kinetic equation here. Now not yet, because you are using the diagram, this diagram. Huh? No, this one RG is here. RG is here. You take this one multiply by this length, you get moment, correct? Then this one, what? This is moment. What is missing in my calculation? Yes, missing alpha here. Ig is 1/12 ml square. You only have Ig, you don't have alpha. So there's a typo error in my calculation. So if you write this one, if this question come out in assessment, lack of alpha, you miss whole mark. I don't give you full marks. Means wrong equation. Okay. If you do certificate level, I still can give you marks, but diploma and above, you need to be careful in your calculation. All right. So now another calculation, you use IO alpha. This is based, the first one is based on what you draw. Second one, you use equation. Now try to differentiate this one and this one. Okay, so this one is same. Moment at O, you look at free body diagram, but this one you look at your kinetic diagram, but you're using IO. IO equal to 1/3 ml square, that one. Why you can straight away use 1/ml square and not use the Ig plus md square? Why? Yes. Where is your O point now? Your O point is here. So what axis you refer? X prime, Y prime. Refer to here, straight away use this equation, rather than you go and find IG plus MD squared. You can still go ahead and go and find this one plus MD squared. You can still find this equation. Same. Okay, but they from the table straight away use this value. Okay, so that's why here you can. But IO equal to, if you use O, if you use here, you need to calculate here. Then you need to add D here. You are looking at this point O. You need to calculate the D here. You still get, at the end, you still get this the same equation. Can but you give yourself a long way.
The example is okay.
G is the first part. Now I'm showing you what happened if you use O point. You don't mix between G point and O point. Okay, so this before this, you get all this answer by based on G point. You refer to O point, you still get the same answer one. But only there's a change of formula that you use. If you use O point, you use IO. But from this case, I'm showing you why I can straight away use 1/3 ml squared. Why I don't use IG plus MD squared. I can still use IG plus MD squared for IO. But I still go back, I still get 1/3 ml squared if I substitute the value here. Okay, so because if you substitute this one, IG equal to 1/12 ml squared, this one ml squared, you simplify, you still get 1/3. Okay. Right. So there are two methods. So it depends on question, but we will highly recommend you go for the central of mass first. You do for IG first. Then if IG cannot give you answer, or you already find the answer, you want to double confirm your answer, you go and do IO. But normally don't need lah. Unless the question very specific, want to give you trouble, ask you to use point O in your calculation. Then no choice. You have to use IO. You have to read carefully. Sometimes the question give you trouble, but very specific, ask you to look at one point. In your coming final, you have that situation. You have been told to exactly use that point in your calculation. So look carefully. Don't say, oh, I can do two methods, so I do whatever I want. No. You have to look carefully what question want you to use. Okay, just give you a hint, your coming final, you're being asked to use other point rather than central of mass. Okay, so you just replace the O with other things. Okay, understand that? Yeah. So for example, if you're bicycle, so there's a person. So there's a wheel A, wheel B, I ask you to focus on wheel A. What is the moment based on the back wheel, for example? Okay. All right. So example 10, still same. You look at the body, look at the system. You have one fixed point, and then the question will ask you something about the object. So you're given the mass, the gyration k. So you're given gyration, you know that you need to use, you're forced to use, if you're given gyration k, you're being forced to use this equation. Sorry. To check, there's one formula for use this one. Then ignore the chord, and you're having the mass of so and so. If the block is released, determine the drum angular acceleration. Okay, so you look at the diagram, you read the question, and then ask yourself, what is the question want me to focus on? In this case, you want to focus on drum. What is drum here? Not here. I want to focus on this object. So, and then on this object, I was pinned to a certain point. So when you have a pin, there's a positive y, positive x. Right? It depends whether you want where you want to do. And then the central of O is same as my central of mass. O is on my central of mass. Right? And then it tell you, okay, you have a mass of 60 kilogram. Okay. Sorry. Drum is 60, block is 20. So when you release this 20 kilogram, what happened to the disc? When you release this, what happened to the disc, the drum? Rotate what direction? Anti-clockwise direction. So it rotate anti-clockwise. So you have your omega, you have your alpha. Okay, you need to find drum angular acceleration. You need to find alpha. Right? So this one rotate in what motion? Linear or circular? Circular motion. You have one point A. So you have tangent and normal here already. Okay, normal and tangent. And then once you have normal tangent, you can find your velocity, you can find your AN, AT. Again, AN is omega square R, right? AT is alpha R. Okay, V is what? V always tangent one. V equal to omega R. Okay, so this three is basic. Okay, the rest you just build. I have two solutions. Right, I give you the first and two. So first one, you do free body diagram. First solution, I do it separately. Means I look at the drum and the disc, sorry, the drum and the mass separate system. And then later I'll show you solution. I look at it as a single system. So when you break, you have this free body diagram. Weight go down, there's a pin, then there's a tension go pull down. You go to the mass, tension pull up. Okay, so don't make mistakes. Don't copy this one over here. It's a different, it's a coupled. So you have these two free body diagram. Okay, go up positive, go to the right is positive. Okay, then there is a alpha there. Because this one rotate anti-clockwise. So this is the one that you want to find. Okay, angular acceleration. This one, this is what you want to find. Acceleration go down. Here, acceleration go down. Right. Okay. This is the block. Okay, block go down. Okay. Then inertia of the drum, IO equal to mk squared. This one. Sorry, it's not m, it's I. It's I, yeah, not m. I equal to mk squared. So gyration, if you're given a gyration, radius of gyration, k, the question actually forces you to use this equation. I equal to mk squared. Gyration is to find moment of inertia. Okay, so I equal to mk squared, and this one from O. You can put as G also, because G and O at the same location. So it doesn't make any difference. Okay, so you do substitution inside mass, K was given, you get IO 3.75. Okay, remember, unit important. You don't just calculate, then give me one number. If you have give me number without unit, 50% discount for the marks. All right, so you put in the equation, right? Put in all the equation. And here, since you're given gyration, you need to find IO. So you are forced to use this equation. M equal to I alpha. M equal to I alpha. So if you're given gyration, straight away, you know next steps, you need to use this formula already. Okay. So you find IO alpha and then F equal to MA. Change your M X. X is normal direction. So normal direction omega square R. AGY go down is this one is tangent acceleration alpha R. Okay, so nothing complex here. You just substitute. Okay, just substitute. Okay, so just remember here, your drum acceleration go down, there's no normal force. There's no normal acceleration. Okay, why? Because the disc was pinned to a certain location, it cannot move. So there's no normal acceleration, but this is moving downwards. Okay, so you can cancel out. You solve the equation. You solve the equation, you're able to find the answer. I'll give you second method where you look at single body. Okay, you look at from this one, you look at this one. Okay, when single body, just now the two body, you break the chord into two body tension. Now, when you look at single body, you combine these two, no tension in the equation. But there's a weight over here. You have two body now, this one and this one. So you have two W, W2 and W1. Okay, so this is free body diagram. This is kinetic diagram. So kinetic diagram, only this one moving, right? This one was fixed. Although this one rotate lah, but it was fixed by this one. So kinetic diagram, you convert acceleration, multiply by mass, you only seeing force. Why we do this one? The purpose is to, later you find moment. Moment you need to use force multiply by perpendicular distance. Okay. And then for all bodies where it's rotate, you have IO alpha. Okay, how to find IO? By gyration, mk squared. Okay, so the rest you just solve for free body diagram at O point. You close this one, you only see this moment. And here, kinetic diagram at O, you close here. You see one external moment and this moment also. So you have two component in the equation. Okay, substitute, you solve, you get the answer. Okay. All right. Now, the next one is what happened? You have a general plane motion. General plane motion means you have a translation and rotate. Means the object move and then rotate. Okay. So same procedure. If this object it rotate And then there's a acceleration from the center of mass to this direction. Means it move this way and then rotate at the same time. Right? The AG is moving this way, but this body was rotating. So you convert all this diagram into free body diagram. Again, you're still looking at the same thing, although a bit complex, but you're still looking at the free body diagram and kinetic diagram. Free body diagram, you only pull all the force into one diagram. You include the moment, forces for free body diagram. But kinetic diagram, you see, still the same. You take acceleration, multiply by mass, you are still seeing force in the kinetic diagram. Okay. What is different here is that from the original, you're given resultant of A. So when you do your kinetic diagram, you split into X and Y direction. Split this one into X and Y direction so that later in your calculation, F equal to ma equation, moment equation, F equal to ma especially, you can break into X component and Y component. Okay. So that is a trick lah. Okay. Then Ig alpha for rigid body. They always have one more component for moment because of inertia. Okay. You don't see this one in particles. You only see this one in rigid body. Okay. So the rest almost the same. Just that now your mg equal to I alpha. Okay. Ig from the table. Okay. So some problem may be convenient to sum the moment about point P other than G. So sometimes you need to see, okay, here don't have P means sometimes it's convenient you focus on point O, like for example, not G, but you shift to other point. That is some point. Means that if you focus on G, you still cannot find, then you shift to other point. Then you see how to solve. Right? Because sometimes when you focus on G point, everything zero. Everything was zero. You cannot see that all the force because the moment was there, the force is there. But you shift to O point or other point, you'll see the moment come out already. That's the reason where this statement come from. So to eliminate as many unknown forces, so we will use the still the same equation, moment equation, F equal to ma equation, still the same. Okay. Okay, I need to highlight this one. So previously we have one method finding the IC point. I use the ruler, draw intersect one. Do you remember? I teach you to find the velocity. You put your ruler, you draw point, put ruler, draw point, then you find one. Okay. So this one, there is a particular type of problem that involves uniform disk, body of a circular shape that rolls on a rough surface without slipping. You will be seeing this one many times for chapters 6 and chapter 7. So without slipping, you use m equal to I alpha, but now you're using IC equation, which is here. Right? Again, how you find this point? You just use your ruler, 90 degree, go down, you find the point. Okay. Okay. So this, for example, this application question, if you're looking at the wheel, this one, the front one, you change this scenario into free body diagram. So there's a pin at this point. So you have gy, gx. Then there's a weight for this front wheel here. Weight will go down through center of mass. Then this one, if this one move forward, this wheel will rotate anti-clockwise, right? So when anti-clockwise contact with surface, you have friction force. Okay. rotate this way, okay, different force. There is a normal force. Okay. So this is free body diagram on the left. On the right is kinetic diagram. So again, kinetic diagram, you no longer see individual acceleration, but you need to use the product of mass multiplied by acceleration become forces. In this case, acceleration at the center of G go to the left-hand side. And then it rotates anticlockwise. Once the object rotate, you have I alpha. Okay, when you have rotate, you have I alpha. And you solve based on all the moment at G point, F equal to ma in X and Y direction. Okay. Okay, we solve for one more, then we have a short break. Okay. So you have this pool. So you are given a G, the small radius and big radius. So actually you have it's like a yo-yo. So you have inner radius and out radius. So you are pulled with inner radius of 100 Newton, and then there's a point A here fixed to a cord. Okay, determine angular acceleration of the spool. You need to find alpha. The spool have mass 8 kilogram, radius of gyration k. So use moment equal to I alpha. You come by one set on. Do this one. Next step is to use this one. After this one, F equal to ma. Okay. The chord ignore the mass. Okay, how to find? So if you pull this one out, what happened to the G? What happened to this point? If you pull this one out, where is the acceleration? Go up, huh? If you pull this one, you focus on G. If you stand at G, you feel that you are actually moving up. So acceleration move up here. Right. So free body diagram, kinetic diagram. Again, you have 2 points there. Put G, put in W. This is tension. So there's a force over here, not outside, here. Then at point A, you have one tension cable there. Kinetic diagram. How you draw kinetic diagram? What you put in first? The G point first. Then? Huh? MA, where's MA? Huh? Yeah, where? Point G, huh? Then, again, rigid body, you have IG alpha. Although it's not mentioned in the question, rigid body, you have one more moment because of inertia. Okay. Again, this one I don't need to explain. You are given gyration, you need to use I equal to mk squared. Okay. So basically, you are halfway solving the problem already if you already understand how to draw free body diagram and kinetic diagram. Remaining is just solving linear equation. So 3 linear equation, moment equation, F equal to ma. Okay. Okay. So solution 1, mg equal to ig alpha. Substitute. Again, F equal to ma. This object do not move in x-axis. A 0 in x-axis, but it move in y lah. Okay. So in this case, the spool roll without slipping at point A. So point A, roll anticlockwise, collinear motion. So you can calculate alpha r. Acceleration is in tangent direction. This one turn in this direction, right? Okay, so you put in, you calculate, then you solve, you're able to find. Okay. Okay. Right. Solution 2. Data. First set already, you use mg equal to ig alpha. Second set, you use moment. Moment in free body diagram equal to moment in kinetics. But now you focus on A. Moment at A, you close here, you see two moments, one here, one here. If by default anti-clockwise, in this case, I follow the motion of this. By default is anti-clockwise, positive, but in this one, I rotate clockwise. So all my moment will be positive clockwise. So here, if I close A, this one give me anti-clockwise, so I get negative. This one positive, right? So what else? Okay, then kinetic diagram at point A here. This one you cannot run already because of moment and inertia. So you have Ig alpha. Then you have one acceleration over here, right? So Ig equal to alpha r. You substitute, you still get the same answer. Okay, third equation, third method. Right? If you want to give yourself problems, go method 3. But here you use IC point. So you use still the same, m equal to IC alpha or I alpha, still the same. Here you convert your A as your IC point, and you calculate the second moment of inertia at point A. So you have no issue for the free body diagram F equal to ma, but you focus on A. But now you are using moment of inertia at A. So again, if you shift your point, you need to use Ig plus md squared. Okay. Right. Ig from the graph, from the table. D, you calculate the distance from the center of gravity. Okay, you still get the same answer. Okay. Okay, we stop here. Okay, 10 minutes breaks. We continue 9:05.